Okay, so last time we had some requests for algebra and geometry. So we're going to start with some algebra type questions and then move on to some geometry type questions. Each of these sessions will be about an hour long. So our first question is based off a pattern. It says I think it's supposed to say 1. Sorry, I typed this up and I think I just have a typo. One section in a stadium has 32 seats in the first row, 36 seats in the second row, 40 seats in the third row, and so on in the same increasing pattern. Which equation represents the number of Y seats in row R? So we're looking for a pattern. And I'm going to send a quick message to someone who's trying to get in and make sure they have the correct code. Okay. So when we have a linear pattern, this one is specifically a linear pattern. They might want us to actually find this equation. So in general, the linear pattern equation is the output letter or variable equals the starting amount plus the changing amount. Sometimes they call it rate of change or slope times the input variable. And I put it in such general terms because we've got to apply it to a lot of different situations. A lot of times the output variable is Y and the input variable is X, but not every time. But in general, if they have a Y and an X, usually the output variable is Y and the input variable is X. So on our question, we have to figure out what each of these would be. So these are going to be the letters. We have to figure out which letter goes where. And this will be actual numbers we're going to put in. Okay. So the numbers are usually the easiest to find. Let's actually start with those. So we want to find the amount of change. We start at 32, we go to 36, we go to 40. How much are we going up by every time? What are we changing by between each set of numbers? Good, 4. We are adding by 4 every time. So we did just have someone join just to catch them up. We're doing an algebra problem right now, specifically looking for a linear pattern. And in general, a linear pattern equation, this is the actual equation in very general terms. We've got to fill in the letters and the numbers. We found the amount of change is 4. So the amount of change is this 4. At the same time, we can figure out the letter. What's changing is the number of seats in the row. So row should go with this changing amount. Usually you can see this changing amount goes with this specific variable because it was 32 seats in that row. They're usually related together. So then we need the starting number. Now the starting number can actually be kind of tricky because the starting number should always be for 0. They didn't say anything about a 0 row. They said the first row and the second row. So we actually need to go back because this was the first row, this was the second row, this was the third row. We need to go back and pretend we have a 0 row just because the starting amount always goes with a 0. So if we were to go back one set of rows, What number would that take us to? If we're going forward, we add 4. If we're going back, good. Lisa says 28. If we go backwards, 28 minus 4 is, or sorry, 32 minus 4 is 28. So that is our starting number. I'm going to rewrite this variable. It's just written kind of weird. When I write with a mouse, they can sometimes end up looking weird. So then we only have one variable left. What other letter did they tell us to use that we haven't used yet? Good, the letter Y. So Y equals 28 plus 4R is our correct equation. Now, what if you forget? You're like, I don't remember where I put each variable. I don't remember which part goes with the starting number and which part goes with the rate of change. If it's a multiple choice question, you can use some of the information to check each answer choice and see if you come out with the right thing. So for example, you could say, okay, first row, that's the number 1. I'm going to try equation A. And I'm going to try plugging in row 1. Multiple choice is great because oftentimes you can use the answer choices to help you figure it out. So we would simplify this. We do have to remember order of operations, which says you do multiplication before you do addition. We need to do the 4 times 1 first, then add the 32. So 4 times 1 is 4, and 32 plus 4 is 36. So when we plugged 1 in, we got 36, but the question said the first row should only have 32 seats. So doing this method, we say, well, it's not A. Then you do have to try the next one. So it can be a little time consuming because you have to try each answer choice over and over again. But if we plug in 1 to the second answer choice, 4 times 1 is 4, and then 28 plus 4 is 32. So then we say, yes, that's the correct answer. It came out with the right number. So just an option if you forget, again, this general equation, because sometimes it's hard to remember that stuff. If you have any questions, let me know as we go through. I'm going to go to the next problem, but let me know if there was anything you had questions about, and I'm happy to answer them at any time. So another linear pattern. In the chart below, the height in inches of a burning candle is measured over time in hours. So they give us height and time. Assuming the data is linear, so they said assume it's linear, that can help us knowing that it's linear. Which function represents the height of the candle over time? So if you do remember linear, then we can know that A is not our answer. X squared is not a linear function. Linear functions always go variable equals the starting number, and I'm just going to use y and x for now, so there's not as much writing, plus the change times x. And there's no x squared, it's just x. So if you remember what linear is, you could eliminate A. If you don't remember, then we can do a couple of methods. We can do the plug it in and check it out, or we can try and figure out what's the starting amount and what's the change. So let's try, last time we did the equation method first. I'm going to show you the plugging in method first on this one. So again, let's say you don't remember that linear means you can't have an x squared. So let's just try all our answer choices. And you might also notice this f of x. This is a weird notation. This is not f times x. I know parentheses almost always mean multiply, This is a fancy way of saying the letter y. You could write y here and it's the same thing. Y equals x squared plus 9, exact same thing as f of x. They use that notation because you could say f of 1, and that means plug 1 in wherever we see x. So I'm choosing from our table, that was a bad 9, I'm going to rewrite it. I'm choosing this 1 to plug in. And we're going to see if we come out with the 9. We want it to be a 9. So when we plug it in, we again have to follow order of operations. Do we do the exponent first or the addition first? Should I square that or should I add? Square. Good. If you don't remember order of operations, let's write it out just so we can review it. Never hurts to cover it again. Sometimes you remember it as please excuse my dear Aunt Sally. That's kind of the little saying we use to remember it. And it tells us the order to do things. Parentheses come first. Any exponents come next. Multiply and divide are actually kind of grouped together. If you have a whole bunch of multiplication and division, you go left to right. And then add and subtract are last. So exponents comes before addition. So 1 squared you can plug into a calculator, or we know it means the same thing as doing 1 multiplied by 1. So 1 times 1 is 1, plus 9 is 10. So did that come out to be the number we wanted it to? Does it match the table correctly? It does not. Yeah. So answer choice A, not our answer. So now we try answer choice B. And again, you can basically ignore this f of x for this kind of problem. We're really just focused on this right side. We're going to plug in a 1. There is a negative symbol in front though, so -1 plus 9. This time we don't have anything else but addition, so we just go to the addition. -1 plus 9 gives us +8. So is that what we wanted? Is that the correct answer? No again. We should have gotten a +9 coming out if it's the correct answer. So this method can be time consuming. We've already tried A and B. Now we have to try C. We're going to replace the x value with the 1 again. So now we only have addition again, no exponents on this one. 1 plus 10 is 11. Still not the answer we're looking for, still not the 9. So then that means D has to be our answer. If you're worried, you're like, maybe I did something wrong or plugged something in wrong, you can still plug it in and check. So D, we're going to plug in 1 for x, and there's that negative symbol in front. So -1 plus 10 does give us the value of 9. So using these answer choices is just a really great strategy because you have to remember less things overall. If you wanted to just do the equation method, a table always tells us what the correct variable is. The table always has x first and y second, or they could call it f of x instead of the letter y like they did here. Or if they wanted to even be a little bit different, they could use t for time and h for height. Usually it's the first letter. So we know from our answer choices, though, that it's the f of x and the x. So we know that's the output, we called it on the last page, and the x over here. So then we have to find the numbers, the change and the starting amount. This table is kind of tricky, though, because we're not going up by 1 every time. If we just went up 1, 2, 3, it's easier to tell. We want the amount of change for just 1 hour. So we're going to have to do a little bit of critical thinking when we figure this out. So for the height, what's the change in height when we go from a 9 to a 7? Are we adding a number, subtracting a number, and what is that number? We are subtracting by 2. Minus 2. But that's for a 2-hour time period. We want that amount of change to be just for a 1-hour time period. So if we change by 2 over 2 hours, how much are we going to change by over 1 hour? Subtracting by 1. Yep, so 1 hour of change would be subtracting by 1. And basically all we do is take this number and divide it by the time. -2 divided by 2 gives us a change of 1. So we have a -1 in front of that x. So then starting amount, we said, always goes with 0. We have to go back to the 0. We have to do that backwards process. So if we go backwards, instead of subtracting by 1, we would go back up. So that would take us back up to a height of 10. So our equation is f of x equals 10 plus the -1x, which doesn't look exactly like any of our answers. You can rewrite a few things or change things around and have it still be the same thing. You can change the order and you're still fine. If we put the -1x first, that's the same thing, and then the +10 second. But the negative sign does have to stay with the x, the positive sign does have to stay with the 10. And then if there's ever a 1 in front of a variable, they're not going to write that in. They're going to drop that 1 off and just write -x plus 10. So 2 ways again, we solved it 2 different ways, but you get to the same place. So option 1 was try your answer choices. Option 2 is, if you remember this linear equation of y equals the starting amount plus the change times x, you can find the actual equation that way. So one more algebra problem, and then we're going to move on to some geometry. Hector and his friends went out for pizza. Altogether, they have $30 to spend. The equation for the total cost of pizza and drinks is C equals 20 plus 2.5x, where C equals cost and x equals number of drinks. What is the greatest number of drinks they can purchase? So this time you're not finding the equation, you're just going to use the equation. And it said they have $30 total. So again, when it's multiple choice, using these answer choices is often the quickest and easiest. Maybe not quickest, easiest, definitely easiest. Sometimes it's easiest to just try each answer choice. So answer choice A would be 2 drinks. So if we plug 2 in, we should come out with that $30 total spent. And when we have that 2.5 next to the x, there's something going on here that they don't have written. Is this 2.5 plus x? 2.5 minus x? 2.5 multiplied by x, or 2.5 divided by x? What actual math operation is going on here? You have a number touching a letter. Is it addition, subtraction, multiplication, or division?
Multiply.
Good. Multiplication. This is times. And that's good to know because when we plug in 2, we need to know that we're multiplying by 2. Good job, guys. So order of operations, again, says multiply first. I need to bring up a calculator. So we do the 2.5 times the 2 first, which gives us 5. So 20 plus 5. And now we can do the addition. Gives us 25. We know they spent 30, so it's not the $25, which means it wasn't 2 drinks. So we tried that answer choice, and now we try the next one. So 2.5 times 4 this time. So again, we go to our calculator. 2.5 times 4 is 10. And 20 plus 10 is 30. And that was the amount they spent. So that means they bought 4 drinks. So that was our algebra for today. We have done some algebra in past sessions as well. I have all of those recorded and posted on my YouTube channel. When I send out the link for this one today, if you haven't already been to my YouTube channel, you can find all the other videos there. So now we're going to move on to some geometry. And we're going to talk about triangles and then perimeter and area today. So triangles can be tricky because there's a lot of different names for all the different types of triangles. Some of it is just knowing what are all these definitions and what do they mean when they say these names. So triangles, when you look at a triangle, it has 3 different sides. The sides are the outside lengths. If we were to name them, they usually use capital letters on the outside. And like that purple side I have, they would call it side AB. You start at A, end at B, so it's side AB. Or side BC was the one I had in green. Or the bottom side. I'm sorry, I'm not tracing over it super well, but they should just be following the lines that were already there in black. So the bottom line would be AC. So 3 sides, and there's the space inside. These are called angles. It's the distance in between the 2 lines. So this would be angle A. This angle up here would be angle B. And over here, this would be angle C. So 3 sides, 3 angles. And we can give each triangle we see a name based off those 3 sides and those 3 angles. So based off the angles, we have acute angles. That's where all the angles in the triangle are less than 90 degrees. And when we say 90 degrees, our right angles look like a corner of a square. So if you're less than that, that's acute. Obtuse, you have 1 angle only. You can only have 1 obtuse angle. So 1 angle is greater than 90. A right triangle is 1 angle is exactly 90. And equiangular, that's kind of a big long word, but you can kind of hear the word equal in it. Equiangular means all the angles are the same. Equal. For the sides of a triangle, scaling means no sides are the same, no sides are equal. or congruent. You'll hear the word congruent a lot in geometry, and that just means equal, basically. And then isosceles is two sides are equal. And equilateral, again, you can hear that word equal in it. Equilateral is all sides are equal. So in a geometry picture, don't ever assume from the shape you know exactly what it is. It looks on this triangle that all three sides are different, but we don't really know for sure unless they give us some sort of labeling. So you'll see these marks on the side of a shape. It'll just be a little tick mark in the middle of the line. If there's a different number of tick marks, that means these are different sizes. Let me show you what an isosceles triangle would be marked as. If we have two sides the same, they would each just have one matching tick mark. This left side is going to equal this right side. And then they could mark that the bottom side is different by putting 2. So if all three sides are different, we would call this scalene. And then they would have to mark the angles inside or make it very, very clear whether this is acute, obtuse, or right. I'm going to just mark the angles inside. So that we know for sure that there's one angle bigger than 90, so this is obtuse. So the whole name of the triangle is obtuse scalene. So how about this triangle? And let's assume all the angles are smaller than 90. So what name would we give this triangle if all the angles are smaller than 90 and two of the sides are the same?
Acute equilateral.
Close. Acute, because it's less than 90. Equilateral is when three sides are the same. Instead of saying all, let me make that more specific. 3 sides. What about with just 2 sides the same? Oh, good. Isosceles. Someone wrote it as a chat. Isosceles. And let me change that for equiangular as well. 3 angles are the same. Okay. So they'll use these terms. Often they won't just say, name this triangle, but they might throw out, you're working with an obtuse isosceles triangle, and they will expect you to know what that would look like. So if they just said, you're working with an obtuse isosceles, you would know at least one angle is very, very wide, and 2 of the sides are the same, but the third side is a different length. So inside of a triangle, there are always those 3 angles. Yes. So good question. I'm going to go back because we got a question. It says, it's acute isosceles because although 2 sides are the same, they are less than 90 degrees, right? Yes. So acute isosceles, these are based off 2 pieces of information. Isosceles because the 2 sides, let me give it some labels. Let's say this was 8 centimeters, and this was 8 centimeters, and this was 6 centimeters. So that tells us it's isosceles. Acute is because of the angles inside. Let's say this is 70, 70, and 40. Because all these angles are smaller, and you could look at the picture this time and see, well, these are less than 90. Because all of these angle measures are less than 90, that gives us the name acute. So the angles inside tell you the first part of the name, and the sides on the outside tell you the second part of the name. You're welcome. Okay, so now that that's clarified, let's talk about the angles inside a triangle. So inside a triangle, you'll always have those three angles, and they always actually add up to the same amount. No matter what your triangle looks like, the three angles inside of a triangle, I'm just going to call them angle 1, angle 2, and angle 3. Those three angles always add up to 180 degrees. There's lots of proofs and stuff, but those are usually make it more complicated. So just believe me that no matter what numbers are inside here, those three numbers have to add up to 180. If they don't, you don't actually have a triangle. So if we want to find a third angle when we know two others, and we know it's supposed to equal 180 total, what can we do to find that third angle?
Subtract.
Subtraction. Good. If we subtract the two numbers we already have from the total amount, that gives us our last angle. So 180 minus 85 minus 28. And then minus the 28 is 67. Good. And you could also have added these two numbers together first and then just subtracted that total. If we did 85 plus 28, we get 113. And then you could do the subtraction. And it would come out still to the 67. So now we want to talk about perimeter of a triangle. We've talked about how to name a triangle. We've talked about the angles inside and how much they should equal. Perimeter of a triangle, and perimeter of any shape really, perimeter is adding up the outsides. So if they give you a triangle and they ask you to find the perimeter, you're adding the outside. If they give you a square or a rectangle, any shape made up of straight lines, add the outsides together. Do you have a question, Erica?
Oh, no, I'm sorry.
Sorry. Okay, just making sure. So this particular question says triangle ABC has a perimeter of 31. So they are kind of being tricky. Instead of just giving you a shape and saying to find the perimeter, they're saying you have a triangle. I'm going to call it ABC. We already know the perimeter equals 31. And then they give us some more specifics. If AB equals 12. So it helps to draw the picture because I want to actually label this. I drew a triangle. I called it ABC. If you drew a different triangle and put the letters in different places, that's okay. If you draw any triangle and you label the side that you have as 12, it's still going to work out. BC is 10, and we want to find CA. So again, they did it a little backwards. They didn't give you all three sides and say, find the perimeter. They gave you two sides and said, use what we know about perimeter to find the final side. So if perimeter is adding up all these outside amounts, 12 plus the 10 plus the AC, we know that should equal the 31, the perimeter they've told us. So what do we do with these numbers to find that missing piece? How can we figure? Okay, first we can add the 12 and the 10. So we're getting closer to the answer. So what's our last step? How do we figure out that last number so that we could know what 22 plus the number we're looking for is to equal 31? Subtraction, good. When we're working with equations, if you set up an entire equation, then to move something over, we subtract it. Or if you're just using some logical thought process, you can say, well, normally I add, but they're having me do this backwards, which means do some subtraction again. And 31 minus 22 is 9. So that means CA equals 9. Now this one wasn't multiple choice. If this were a question where you had to do one of those free response answers, you would want to actually write a sentence. You would want to draw your picture out like we did, and then you would want to say the side CA equals 9. You want to make sure to be very specific and to write it out so that you get the points. Those free response questions, the more you lay out and the more specific you are, the more points you might get. So we can also talk about area. So perimeter was adding up the outside amount. Area is finding out how much space is inside the triangle. If we wanted to lay tile down or put carpet down in a space like this, we need to know area, or like paint it. So you'll notice I added in the reference sheet. This is the sheet you actually get on the OGT. You may want to download it yourself and become very familiar with it. It's good to know how to use this. And you'll see they specifically have an area formula column. Area formulas column. So on our area formulas, we can go down to triangle. But we have to know, what do all these letters mean? So area formulas, the A stands for the area. B and H. B stands for the base, and H stands for the height. So now we can plug our information in. 1/2, we talked earlier about having a number next to a letter really means multiply. So 1/2 times the base times the height. So on the triangle that's given here, which number is the base of this triangle? The bottom of the triangle. The audio is choppy, I heard. I'm going to try and up my microphone levels, but I'm not sure if I can do anything other than that. Oh, yeah, my microphone levels were way weird. Is that any better, hopefully? I'll wait and see if I get an answer for that, but while we're waiting for that,
Yes.
that is better? Okay,
Yeah.
Sorry about that. Thanks for letting me know. Anytime something like that happens, please just let me know and I can see if I can figure out what's going on. Oh. For one person, it did not get better. I am not sure of anything else to do. I apologize. I'll try and make sure my microphone's really close to my face, though. Okay, so Lisa said, though, that the base is 18, and that's correct. So let's go back to the problem. So then the only other number is, that's a 5. Sorry, it's kind of a badly written 5, but that's the height. Inside the triangle is the height. So 1/2 times 18 times 5. When you plug this into your calculator, you can type the 1/2 in as 1 divided by 2. So we go to the calculator, we clear it out. 1 divided by 2 times the 18 times the 5. And once you've typed it all in, we get 45. And order of operations wise, even though it says PEMDAS and it says multiplication before division, when it's multiply and divide, you really just go left to right. If that's all you have to do, go left to right. So let's move on to some other shapes. This is a rectangle. This is one of the easiest areas out of them. So rectangle, we go over to our formulas, and it's length times width. So for our rectangle, what is the length? Good, 12. And our width is 5. So then we multiply these together. 12 times 5 gives you 60, I'm pretty sure. I'm going to double check that just to make sure. Yep, okay. Now, you'll also notice on this one, I put centimeters. When you write an area, you're also doing the centimeters times the centimeters. So when you write the answer, you get centimeters squared. So anytime you have these units where it's squared on the centimeters or inches, any units, this means it's an area. We also have a trapezoid. So a trapezoid looks like you took a rectangle and extended its sides out. Yeah. Or like a triangle mixed with a rectangle. So a trapezoid is this formula. Area equals 1/2 times height times base 1 plus base 2. Again, even if we have this formula sheet, we need to know what each of these numbers mean. So on a trapezoid, the two bases are the top and bottom. Normally, it's these sides across from each other. They could actually write the trapezoid kind of sideways, and then the bases are actually the right and the left. It's those two straight lines across from each other, though. So now we can write our numbers in. If the top and the bottom are the bases, which of these numbers is the height in our shape?
8.
Good. 8. And then the bases, doesn't actually matter which one is, you could do 10 plus 22 or 22 plus 10, and it's fine. Order of operations wise, though, we do have to do inside the parentheses first. This one is more important to remember the order of operations on, because you've got to do that addition first to get 32, and then we can just go to the calculator and plug it in. When we plug in the fraction 1/2, that again is 1 divided by 2. So 1 divided by 2 times 8 times 32 is 128. Again, if they give you units, this would be inches squared, or they could say squared inches. Sometimes they write it out in words. That would be the exact same thing as 128 inches squared. So one more area shape we haven't seen yet is the parallelogram. So our parallelogram is actually a very similar formula to a rectangle. Base times height. Rectangle calls it length times width, but it's still the same process. We just multiply the two numbers together. So on this shape, what's the base?
35.
Good, 35. So 35 multiplied by the height of 15, the height was that number inside. This one I just need the calculator for, I don't know the answer. That's 525. And then if we use the units, that means millimeters squared. Okay. So those are the basic formulas. Usually they give you something a little more complicated to do with them. Okay, so one example of them kind of changing it up and not just saying find the area of this is to give you an area, kind of like our perimeter question. So they give us the area of a rectangle is 234 meters squared. If you don't remember what each unit stands for, that's not usually super important. Just know M is for meters, but if you don't know what the actual M stands for, know that the squared means area. This is an area. If length equals 18 meters, what is the width? So we still go to that formula for a rectangle. Area equals length times width. And we plug in what we know. This time we know the area. A is 234. And we know the length, but we do not know the width. That's going to stay as a variable. So how can we find the width? What's our opposite operation? When we're working with equations, we always do the opposite. Good, division. So we're going to divide by the 18. We want to get rid of the 18 that was next to the W, so we move it to the other side. So 234 divided by 18 is 13. Now, since 13 is not an area, the width is not the entire area, this would go back to not having a squared on it. It would just be meters. Another type of problem where it can get a little more complicated is when they put a whole bunch of shapes together. So the easiest way to attack something like this, when there's just a whole bunch of shapes together, is to separate them into shapes we know the areas of. Let me get that formula sheet up really quick. I thought I already had it in, but it helps for us to look at it as we're working. Okay. So we have a parallelogram down here. We have a rectangle in the middle, and we have a triangle at the top. We need to look at each shape individually and find the areas of each shape. Now, I did forget in this original picture, I should have included one more piece of information. Now we can go and do it. So if the bottom shape is a parallelogram, what's the area of this green parallelogram at the bottom? $50. Area of a parallelogram was base times height, so 5 times 10 is 50. Okay. Now we have to get a little bit trickier with the rectangle. On our rectangle, we only have one thing labeled as well. But this one I did intentionally actually leave off and not labeled because we have to use some other information. We have to know on a parallelogram that the left and right side are exactly the same. If this were 4, this would be 4. And the top and bottom are the same. So sometimes you have to take the shape and use that information to find the other side. Now that we know the other side, what's the area of the rectangle? Good. Area of a rectangle, length times width, so 10 times 8 is 80. And now we have the triangle at the top. Again, just like the parallelogram, we know on a rectangle, if the bottom of the rectangle is 10, the top of the rectangle is also 10. So once we've moved that information around, now we can do area of a triangle. So what would the area of our triangle be? Okay, close. 60 is the 6 times 10, but there's one other part of a triangle area. It has that 1/2 in front. So what do you get if you do 1/2 times the 60? I'm pretty sure you meant 30 and not just 3. 60 divided by 2, or 1/2 times 60, is 30. Yep. Oh, I already wrote the 30 in. So does that make sense why that's a 30? If you have 1/2 times the 6 times the 10, that's a 6 inside for this triangle. Yep. So now that we have all 3 areas, we just add them together. You turn it into shapes you know, and then just add those areas together. 30 plus 80 plus the 50. Oops. Careful on your calculator, it's easy to hit the wrong button. 30 plus 80 plus 50 is 160. So the total area of this entire shape is 160. And since it was inches, that would be inches squared. Okay. So that's all I had prepared for today. Practice-wise, if you guys want practice problems, the best place is to use those Ohio tests that have been released. It's good to practice the questions that, you know, they've said this is what they're going to look like. You can also check out your local library and see if they might have an OGT test prep book. They usually have some good questions that are very similar to the OGT test itself. I also sent out the playlist of the YouTube videos I've made that were not our group sessions. And again, I'll send out the link to this YouTube video. You can find that playlist on my channel, and there will be a lot of just individual topics with those videos. Or if you missed any of the group sessions, there will be those group session videos from before too. So any other questions before we end for today? Okay. And if there's any specific, oh, sorry, go ahead.
Do on the OGT practice test, do the solution table be next to these type of problems, or do we have to memorize that table?
Oh, the table I'm showing you right here?
Yes.
Yes, this you have access to. They actually give you a copy of this. I don't know if they place it at the beginning. Okay, so someone who's taken it before says it should be at the beginning. Some types of tests you can actually rip it out, but some you may just have to go and look back at the beginning.
Okay, thank you.
Mm-hmm. Yep. Yeah, so these are all things you don't need memorized because you can look directly at this page. Good questions. Okay, well, thanks again for joining me. We'll have a couple more sessions next week, and feel free to text or email me at any time if you have any other questions. Have a great day.
Goodbye.
Thanks.